Thank you very much for coming in to this talk, Brick by Brick, Building Open Source Libraries. My name is Nicola Corti. I'm here together with Paolo Rotolo. And as you can imagine from the title, today we're going to talk about open source, and we're going to talk about Legos, which is always fun. But first, mandatory slide about ourselves. I'm a Kotlin GD. You can find me online as Corti Nico. I maintain a lot of libraries all over the places. And Paolo, please introduce yourself.
Hi, everyone. I'm Paolo. I'm an Android developer, work at next to me. And in my free time, I like to contribute to open source and also play piano.
Awesome. So to give you a little bit of a frame of reference, both me and Paolo are quite involved in the open source space. And I'm just going to mention some projects that we both collaborate to. So first, I'm the maintainer of Detect, which is one of the most popular static analyzer for Kotlin. And I also support Chucker, which is an on-device debugger for OKHTTP and Android apps. And most importantly, both me and Paolo are the maintainer of AppIntro. Paolo particularly is the original author, and I joined him in, I think, 2018 or so? Yeah, as a co-maintainer of this library, which became quite popular. Paolo is the original author, though. And today we want to bring our experience to the table and share you tips and suggestions on how you can actually build your library and bring it to success. So whenever I think about building open source library, I like to think at my library as if it's basically a business. Like you're sort of running a startup, and you need to think of all the life cycle of this startup, like how you build it, how you start it, and so on. So today we're going to walk through those various steps. First, how you actually develop your library. So you need to set strong foundations, and you need to build like a building that people will enjoy going to. Then, once your library is ready, you're going to publish it. So you're going to make it available to the public. You're going to open your business for general availability. Then things can go well, but things can also go wrong. So you need to have good care of maintaining your project, because things can go on fire quite easily, both in your code base, and as well in your user base and community. And talking about community, you definitely want to grow your library. You want to have more users. You want to have more contributors. So we're going to see how you can build like a really strong business out of it. Now I'm going to hand it over to Paolo to start talking about developing your libraries.
Thanks, Nico. So in this part of the presentation, you're going to see a lot of snippets of code from AppIntro. So I decided to start by introducing you to AppIntro, which, as Nicola said, is a library that I decided to make in 2015. And I needed it for an Android app that was developing at the time. There was an open source Android app about diabetes called Glucosio. And we needed a way to basically show the user what the app can do and make a process of onboarding for them. And I would never have imagined that more than a few years later, this library would have more than 10,000 stars on GitHub. So right now, AppIntro not only handles the onboarding process, but also lets you ask for permissions at this slide, and also allows some of custom policies that you may want to define for going on with the presentation. So like Nico said, building an open source library is more like building a business, basically. So at the start of your business, you're basically a startup. You don't have a lot of budget, right? So you not having a lot of budget, I think that I learned as an open source maintainer is that you have to learn to say no to things. You have to learn to say no to what doesn't matter and focus instead, for me, of course, in building a great API surface for your library, because the API is just the face that your user will see of your library. So to build a great API surface, you need to write APIs that are elegant, so easy to use, and the user know exactly what they are doing. Do not break APIs between releases, because maybe your user will be afraid to update from one version to another if things break. And finally, make some APIs that are future-proof. So let's start for the first point. So build elegance API. Now, this is a snippet from the Kotlin standard library. And you can, just looking at this API, you already know basically what this method does, what this method, for example, does. So the first one, if the list is empty, returns you an error, right? The second one returns you a null value. So this API is explicit in the naming, and we can say that it's self-documenting itself, right? So yeah, you have to write documentation, of course, but writing in that way your API makes it more readable, it makes it more predictable to the final user. But back to our original API of AppIntro. So in AppIntro, you have like this activity called AppIntro activity that you can extend. And you can use some methods like add slides to your presentation, right? And this was the original API developed in 2015. And we haven't had a lot of change of the API yet. But we did a little brainstorming lately. So I will introduce you to the new AppIntro API that we are developing. So you may notice that we introduced Kotlin DSL for defining slides, and we also support Compose for that. So this way of writing code is more readable and enables the user to be more comfortable with the code, so to construct, for example, different objects with no difficulties. And so a suggestion I can give it to you is that if you have basically a builder, for example, you can migrate it to Kotlin DSL to be more concise and more have a really better user experience. Then you may notice in the bottom that there is a settings section, and we're passing to the settings section a transformer. So in AppIntro, a transformer basically is what AppIntro will do when changing one slide to another. In this case, the transformer is fade, so make a fading animation. And here we are leveraging another feature of the Kotlin programming languages, which is sealed classes. And sealed classes in your API are very important because you already know basically what are all the possible subtypes that this class is gonna implement. And also, since you may have some open classes or abstract classes in your code, the users of your library can extend those classes. So with sealed classes, you can use, for example, exhaustive clauseless in your when. So you can be sure that you cover all the case and you don't introduce some unintended behavior in your library. So for example, in this code now, we are checking if for each transition we have the appropriate code. And Kotlin actually forces you to do that if you're using a sealed classes. So back to our original API, you can also find that we're providing a way to define a simple slide with a title, a description, and an image. So basically, this code gives the user this slide, right? So what if the user wants to do more with the slide? For example, adding a checkbox that might be right in an intro, right? So you basically have to accept the privacy policies, or add a button. Should you add in your API callbacks to a button or something like that? Well, as I was saying before, you have to learn to say no to some things because adding too much APIs in your code might slow up your development. So we just decided to make this API which accepts a custom layout. So basically, the developer can do anything they want, anything complex they want with their slides, and we basically support it with just one API. In fact, the next thing I'm going to talking about is do not break APIs. So less API you have, better you can develop basically faster. So for this section, basically, you have to keep track of all the APIs that you make public. And Kotlin, once again, can help you with that. So there is a mode called the Kotlin explicit API mode. And if you enable this flag in your configuration, basically, in Kotlin, each class is public by default. But enabling this configuration allows you to explicitly say that you want that class public or that function public. So just by seeing the code, you can already find all the classes and methods that are public and are part of your public API, right? And also Kotlin explicit API mode forces you to specify explicitly the type of the returning type of the function and the type of each variable. So for example, if the type is implicit, it's more easy to be changed by mistake. You don't want to break your APIs, right? There aren't only Kotlin users out there. Maybe your API can be consumed from Java users too. So you have to be careful about this too. Because in Kotlin, you might say, OK, I want to add a new parameter to this API. So I'll just use a default value, right? So this won't break the code for my user. But what will happen if a Java user is using that? Well, this is the function that gets generated on the Java side of things. And as you can see, it still accepts two things, even if we are providing a default value in Kotlin. So to tell Kotlin to generate overloads for the Java function, you have to use this annotation, JVM overloads, that will basically generate both the function, even from Java consumers. Also, a suggestion I can give it to you is that don't use data classes in your public API, because basically every change you make to a data classes is not backward compatible. So try to avoid that. And we don't have a lot of time. If you want to learn more about this, there is a talk by Nico. There is one broken API among us. Finally, if you really have to deprecate things, there is once again a Kotlin feature that can help you. There is this annotation which is deprecated, and you can annotate your APIs with that. So you can provide a message for the user, and you can even provide an action. So the IDE will suggest that action, which is, for example, refactor this code to use the new API, and the user can quickly migrate from one API to another, like in this case. And finally, you can pass a level of deprecation. So you may want to start with the deprecation level warning that just gives your users some warnings. Then switch to error, that the code will not compile if the user is invoking a deprecated API. And then switch to hidden. Hidden basically hides the code from your user. It won't show up in auto-completion, for example, in IntelliJ, in Android Studio, but it will still be present in your code to preserve binary compatibility. And finally, we are developing Android libraries, so we have both code and both resources. So don't forget about resources. They are public by default too. So try to not break things appending, for example, adding a prefix before your resources, because maybe if you're using generic names, the clients of your library can override them by mistake and cause unintended behavior. Finally, you have to build some APIs that survives the future. For example, right now, if you are choosing some tools to build your library, well, maybe pick some tools that already support Kotlin multi-platform, because maybe it will be easier in the future to switch to Kotlin multi-platform. And in this slide, you can see some of the alternatives. Also, for the same reason, try to be not platform specific. I know that for some libraries it is impossible to do that, but for example, asking context in your public API can be avoided. So there is a nice library called Jetpack App Startup that you can use, and you can use that, for example, to inject your context in your API. So injecting that context avoids you to ask it from the outside. Again, if you want to learn more about this, there is an article that I wrote on Medium that you can check out. So finally, you have your code done. It's time to publish your library. And you basically have to find a new home for your library. And we took into consideration 3 different platforms that enables you to do that, which are Jetpack, GitHub Packages, and Maven Central. So let's start with Jetpack. So Jetpack, it's very easy to use. It's free for open source projects. And it's a very good alternative for starting. If you want to put your library out there, you just give Jetpack the link of your Git repo, and Jetpack will basically clone the repo, compile it, and upload some artifacts on its platform. So it basically requires no configuration at all. a drawback of that is that you are not providing Gitback the artifacts, so you are not enabled to signing them with your key. So it's, let's say, less secure than on the platform. And it doesn't support Kotlin multi-platform yet. There is an issue that you can track to know when Kotlin multi-platform support will be available. So an alternative to that is GitHub packages, which, if you're already using GitHub in your continuous integration process, for example, you're using GitHub Actions, well, it's really nice to integrate in that. So you can, it's a pro. Then you can share both your code and your artifacts in the same place, which is GitHub, of course. And it supports the Kotlin multi-platform. But I think with GitHub packages is that users are required to provide a token each time they want to use your repo. So the code in your build Gradle will look a little more like this from the client point of view. So it is required to pass parameters, out parameters, even if your library is open source. And then there is the final solution, which is Maven Central. It's very, very, very popular among Android and other Java projects. It's included by default, for example, in Android projects. And again, it's free for open source projects, and it's more secure, as a lot of advanced features. But requires more time to set up. In fact, you have to pass a human, you basically have to ask a human to review your group name, package name, at the first time you set up a Maven Central repo. So we know that this is difficult, but this is open source, so maybe you don't have to start from scratch. There are some templates out there that have already set up this part for you, have already some CI done, publishing to Maven Center, for example, and have already some tools like static analysis tools. So you may check out even some project like this. This is a template made once again by Nicola. And just a little bonus, Gradle source dependencies. What do you think if you could just specify in Gradle a repo, a Git repo, and tell Gradle, OK, take this repo, clone it, and add as a module of my app? Well, this is possible to do. This is supported by Gradle, but this is not supported by Android Studio. So we are getting there. There is a ticket for that too, so you can help voting there if you want that feature. Finally, you publish your application, your library, sorry. You just have to tell the world about it. And to tell the world, you can use GitHub releases to showcase a changelog of the changes. And we also have this little tradition in App Intro, which is thanks the contributors of each release. So you might want to do that. And maybe you can make a blog post about it if you have some interesting development choices that you made. And you can also submit your library to weekly publications like Android Weekly and the Kotlin Weekly that have a section about new libraries. Now, back to Nicola.
Thank you very much, Paolo. So now we saw how to build elegant APIs, and we have our first version out. Where do we go from there? Like, 1.0 is out. Well, I like to think that the first thing that you should do with your users is, well, continuing doing releases, obviously, especially if people start depending on that library. But my take on doing releases is that it's crucial that you set the right expectations with your users. And what I mean with setting the right expectations, I mean doing predictable releases. Like, people want to know when a new version is going to happen, especially if a new version requires to do updates, if introduces new feature, there are like blocking for releasing new Android app and so on. So make sure you follow a schema. There are various, like, two big schemas for making releases. The first one is the so-called feature-based. That means whenever my library has enough feature that I believe it's mature enough, I'm going to release a new feature, a new release. Or there is the release train model, which is I'm going to make a release every 3 months or 6 months or once a year, and so on. This is more popular for projects that have like a lot of commits, or they need to follow like a regular schedule. Like, for example, Ubuntu follows this release train model every 6 months. So make sure you clarify when are your releases going to do and going to happen, and how do you do that? Well, you can have a roadmap file in your repo that explains which new features are going to be included and when are they expected. And obviously also make sure you have proper change logs that explains like what a feature, what a release contains, which features are included, and so on. And so to do all those things, there are various methodology out there in the open source space. I'm going to touch on some of those which might be already known or not. One of the really popular one is called conventional commits. You can find the spec at conventionalcommits.org. And basically, this relies on making sure that every commit, every pull request in your repo follows, the commit messages follows a specific schema. For example, if a new feature is added, the commit message needs to start with feat, and so on. This allows also to track if a breaking change is about to be included. And if you follow this schema, you can automatize tools like changelog generation out of your commit history and understand, like, is there a breaking change on main? Is the new version going to be 2.0 because something is pending and waiting to be released? If you don't want to follow this approach because maybe it's too, like, I don't know, complicated or so, there is another methodology which is called keep a changelog. Again, they have a spec, keepchangelog.org. And as the name says, this instead relies on moving that like structured information from the commit message to a changelog file. So you're requiring every pull request to your repo to update that changelog file so that file is always up to date. That means the contributors or users of your library can just open that file and see, like, okay, what are the features that are in the upcoming version, and like what's up next. Once you follow those approaches, you definitely also want to follow a versioning schema. And for the versioning schema, I obviously recommend to use semantic versioning. If you're not familiar with semantic versioning, it means that your version should follow like a 3-number structure, and you're gonna bump the first major number when you have like a breaking change. So the next version of your library will not be compatible with previous code, with code bases that are using the previous version of the library. You're gonna bump the minor whenever you have a new feature, and you're gonna bump the patch whenever there is a bug fix. Maybe this sounds obvious to you, but I saw a lot of libraries that are not following this approach. They follow like dates versioning, which doesn't bring any semantic information over there. And we're going to see in a minute also how this information can actually be useful to support your repo. So supporting your repo means making sure that your code base is healthy. Like, again, you shipped 1.0, but then the world continues to evolve. There are new versions of HTTP, of libraries, and so on that they get released, and your library don't want to be left behind. So the first thing you need to do is make sure you have a stable CI. Like, you definitely want to have like GitHub Actions, Circle CI, whatever CI works for you, as long as it's stable, is green, like contributors wants to send pull requests, and their code needs to be tested against a CI that is healthy. And then, as I was mentioning, you need to take care of third-party dependency bumps. And trust me, as a maintainer, this takes a lot of time of mine, like, especially when you have like 20, 30 repos, you have like 1 point release of one library. It means 30 pull requests for me. So how do you automate this? The tool that I recommend to use is called Renovate. So probably you know another tool which is called Dependabot. It's from GitHub. It's well integrated. But I actually prefer to use Renovate, which is a separate bot that you can enable on your repo. And once you enable it, he's going to send a pull request to your repo saying like, hey, I'm configuring myself. And I actually discovered that you have several .gradle files. And I'm going to watch those files because maybe there are version numbers over there that I'm interested in. And then in the same configuration pull request, it tells you like, hey, I noticed that your Gradle version is not up to date, so I'm gonna start to send you some pull requests. I will be gentle, so I will not flood you. There will not be more than X pull requests a day, and so on, but this is what to expect. And so I think that the coolest feature of Renovate is actually the auto merge. So here we see a pull request where I got asked to bump Gradle from 8.3 to 8.4. And I have auto merge enabled on Renovate. That means that this pull request arrives in my inbox, the CI runs, so the CI at this point is really crucial. You need to have tests, you need to make sure that everything is tested properly. And then as this one is a minor version change, is not a major, that's where semantic versioning comes into play, Renovate will wait 1 day, and if everything is green, it will just merge it. Like, I don't need to look into it. Well, obviously, things can break between minors, but I hope that the library maintainer that I'm depending on is a good citizen and is marking breaking changes if there are like behavioral changes in their code. So maintaining is not just about maintaining the code, but it's also about maintaining the repository. So the user that are using library and how they interact with it. So there are like a number of tools that can help you when things go on fire. The first one is Stalebot. I'm a big fan of Stalebot. Stalebot is a bot, specifically I recommend the one from GitHub Actions. You can find it at actions/stale, and it will check the issues and pull requests that are not receiving enough activity and just mark them as stale and tell them like, hey, there is no activity here. If there is no activity in the next 7 days, I'm gonna close it. So Stalebot is highly controversial in the open source community because a lot of people mention that this creates like, it annoys external users because, oh, my issue has been closed because no one looked at it. But I actually believe that as a maintainer, you need to use those tools to make sure you focus on what is really important. The barrier of entry to open an issue is so low for everyone that me as a maintainer, I'm flooded with issue reports. Like I get like, I don't know, between all my projects, probably 100 new bugs a day. I can't look at all of them. Like I look at the most important, and I rely on tools like Stalebot in closing those that maybe you were trying that library, you didn't configure your environment properly, and then you forgot about it. Why should I invest on that? I can try to look into it, but you don't care about it anymore. So that helps to make sure the quality of your issues stay high and you focus on things that are really important. To help with engagement on your community, you definitely want to have a code of conduct, which is like a file in your repo that explains how you expect users of your library to interact with your repository. It's just a file, but GitHub is a bit smart and shows the code of conduct in various places. For example, if a user attempts to create their first issue in your repo, it will show a pop-up saying like, hey, make sure you check the code of conduct. And now you might think, okay, people don't actually look at the code of conduct that often. I don't know, but then that's why you need tools to enforce the code of conduct. One tool they really like is the interaction limits of GitHub. Not a lot of people know about it, but actually you can limit the interactions of your repo to only users that have their account for more than 24 hours. So if you have like someone that just created an account on GitHub and wants to spam your repo to, I don't know, drop links of gift cards or spam whatever, and trust me, I work on repos that receive, like sometimes receive 100 of those spam issues like in 1 hour. So those kind of tools really help to protect your repository and make sure that the issue tracker is healthy. Like you don't want people to come to your issue tracker and see like, hey, get scammy gift cards or so. And then I talked a lot about issues, but there is another part of maintaining your repository, which is pull requests. And one tool that I love to use is Danger. So Danger is a tool to automate your pull requests and provide signals to contributors early on. So let's look at a pull request on Detect. Detect is a static analyzer for Kotlin, and someone is sending a new rule. Statement could be exception. Amazing. So when this pull request comes, the first thing that it happens is that we have Danger. So Danger will get this change and will start analyzing it. And as you can see here, it says like, hey, this has been generated by Danger. It's actually Detect CI speaking, but there is some logic behind that analyzes which files have been modified. And for example, in this case, we realize that, hey, the user is adding a new rule because there is an added file on a given folder where all the rules are contained. And then I can check if the user provided tests and provided all the things that we know are good. Or for example, in this case, the user is modifying one part of the website which is unversioned, and we want to tell like, hey, you're about to touch some files. Are you sure about what you're about to do? This is just a warning. And what's the thing? The thing is like, me as a maintainer, I repeat those messages over and over, like every day. Every pull request that sends a new rule, I need to repeat the stuff. I don't want to repeat myself. That's why I use tools like Danger that helps me in this. And this also helps the contributor because they receive the signals as fast as possible. Like how many times you open a pull request and it went in the void? Like, you got no answers. So make sure you use tools like this. You can go one step further and use other automations. For example, we use GitHub Sarif integration to run detect on the pull request and get all the findings and upload it to GitHub so that the user will see comments in line in their pull request of all the violations of styling in their code. So they would see like, hey, here there is a missing new line or so. And I mean, the amount of tools that automate pull requests are like really countless. For example, you can add code cov report to check if test coverage is decreasing or not. So make sure you sort of automate your tasks as much as possible because time as a maintainer is so precious and you want to dedicate it to really the valuable things. Okay, so now we talked about maintenance, and now it's how do you actually grow your project? Like, how do you make it bigger? How do you like scale it? How do you make it flourish? So to talk about grow, I like to use a metaphor from a book and talk about growth models. Like, you need to understand which type of open source project you're dealing with, both as a user and as a maintainer. And there are like various type of open source project. So I'm quoting this book, which is Working in Public, The Making and Maintenance of Open Source Software, from Nadia Iqbal. And she groups the open source projects in 4 sets, whether they have high contributor growth or low contributor growth. So how big is the group of maintainers of the project? And on the other hand, based on how many users the project has. A lot of users, or if it's a smaller project. So I user, I contributor, we have projects that are called federations. For example, Flutter is a federations kind of project. You have like a lot of users, but also a lot of contributors and maintainers, people from Google, people from like external companies that contribute to the open source project. Then on the other hand, you have like projects that have a lot of users, but not many contributors. For example, OKHTTP. Those are called stadium kind of projects, because imagine it's like you have a small team of maintainers, like folks at Square, and the fact of OKHTTP is that like the code is so complicated, so it's really hard for folks to send pull requests that will get accepted. So it's even really hard to become a maintainer of those projects. We still have a lot of users, which are like the spectators of this stadium. And then on the right side, we do have projects that have low users. So in this case, they're more like niche. We have projects which have like a little, like smaller number of users, but still a lot of contributors. For example, Harrow. I picked Harrow because Harrow is more like a niche in the functional programming space. And if you look at the number of contributors, they have like nearly 300 contributors. It's quite of like an involved library. And those are like called clubs type of project. And finally, if you have low users and low contributor, this is basically toy projects, like your small GitHub library that you send out like on your Saturday evening and so on. So why I'm telling you this? I'm telling you this because if you want to grow your community, the first thing that you need to understand is like, what is your model? You need to understand that from the maintainer point of view, but you also need to understand it from the contributor point of view. Like if you try to approach a project, which is a stadium kind of project, you're gonna have a really hard time to contribute. And probably you're gonna be like, oh yeah, doing open source is so hard. So make sure that you understand which type of project you interact with. But so from the maintainer point of view, let's say you really want to grow your community and you want to aim for like a federation kind of things or for a club kind of things. Generally, you definitely need like a synchronous mean of communication. So you probably want to use a chat. There are like various alternatives, definitely Slack. If you are in the Android space, you probably want to ask the Kotlin lang Slack to create a channel for your library, as we did for Apintro, or use Discord. Discord is great because it's free and has unlimited messages. So you can create a Discord for your library and build your community around it. Some libraries even build Twitter profiles where you can subscribe to get updates on when a new version of the library is released and just get promotion on that new releases. If you want to grow your contributions, make sure you also gamify your contributions around your repo. For example, you can run contests. Like, you can open an issue and say, like, I don't know, the first person that will fix this will receive, I don't know, a gift card or a swag or stickers or so. There are like industry-wide contests like Oktoberfest, which is running right now, where you can enroll your library and folks from all over the world can join your repository and start contributing. If you want to go one step further, you can consider organizing meetups, both virtual, like an event where people that are interested just join a call, or in person, like you could potentially organize like a small hackathon or like a get-together. And then one thing that I recommend to use is tools called Zwog as a service. Like if you Google that, Zwog as a service, you will find a lot of services that hands off all the logistics of sending Zwogs. So let's say that you want to send stickers to every pull request that you receive. Well, you will have to ask for the address on a public forum, which sucks, because people don't want to write their address there. And yeah, buy the stamps, go to the post office, send the stickers, make sure they have stickers, and so on. While instead, you can buy a package on a Zwog as a service tool and say, like, I want 100 items. They will give you 100 codes that you just need to hand over to your contributors, and they will go to this platform, use that code, and just get the Zwog delivered at their place. It really automatizes a lot of those processes. Obviously, to do this, you need a little bit of money, because doing Zwogs and sending things around can get expensive. That's why it's important that you grow your sponsorship circles. There are various tools to do sponsorship. I mean, obviously, GitHub sponsors and Open Collective. And one that I want to call out is also Thanks.dev, which takes a different approach to sponsoring by making sure you sponsor your entire dependency tree and not just the big project that everyone knows. Talking about big projects, if your employer has a budget for open source, make sure you check out which dependencies you're using, and you go to your employer and ask them to sponsor some of those projects, because you are the biggest advocate to mention which libraries should be supported. And with this, today we talked about a lot of things, and we hope we inspired you to build your open source library, to reach out to a maintainer, to onboard on a project and just grow your project to success. For me, it was an amazing journey. I got to meet Paolo in this, and I hope your journey starts today or it continues from here on. And with this, we want to thank you very much for listening. I think we have time for one question, or...
You have a slide on broken APIs. What does it talk about? It talks about...
Yeah, and you need to repeat the question also.
I didn't get that, sorry.
You had a slide about the broken APIs.
Yes.
And then you said it was a chat about something which will tell us how not to design a broken APIs, is it? Or
Yeah, there are some tools that will check that for you, and you can find them on the slide that I put in Nicola's talk, actually. So, yes, okay.
I think it's this one.
Yes, this is the one.
Yeah, for context, this is a talk I gave some years ago. It's called There is One Broken API Among Us, and it's all about making sure your API don't break. So there are a number of tools like Binary Compatibility Validator and JAPI CMP that allows you to basically get a dump of the API of version 1 of your library, get a dump of the API of version 2 of your library, and compare each other and make sure that you're not breaking anything in between. Because there are changes which are really subtle, like if you have a function and you have like 3 parameters and one of the parameters changes, and that change might be binary compatible or not based on how the parameter changes. So those tools helps you a lot. And I'm maintaining really big projects. If you are the only maintainer, it's okay, you can do these checks manually. But if you have like big code bases and you need to ensure binary compatibility, you need those tools to automate every pull request and say like, hey, you're about to break people in this change cannot land as it is, and so on. So yeah, there's like video and slides online about this one if you're interested.
also one more thing. So you talk about a lot of things, but regarding the test cases that you have, right, that is an important role, right, to maintain the libraries, right? So how do you, what will be the percentage that you expect from the score coverage wise? What do you think the best library should have?
So the question is, what is the best code coverage? Like, what is the recommended code coverage percentage? Well, I guess I'm going to answer with the classical engineering answer, which is, it depends. Detect, which is the one that we were seeing, it's a library that is really easy to test because basically it's a linter. So for every rule, we ask to have sample snippets of Kotlin code that needs to be tested against. So it's easy to achieve like high coverage there. But like, for example, app intro, it's a little bit more complicated because that needs an emulator. So like, you know, doing emulator testing on Android is more complicated. This is an open source project. We do have some funding, but it's really, really limited. So it's not that we can, you know, buy device farms or so to run those tests. So it really depends case by case. We are at time, but we are around. If you're interested in open source and you want to onboard on our project, make sure you reach out to us in the hallway. Thank you very much again.
Thank you.